Hi, good morning to one and all. Myself A. Ramanjanlu. Today I am going to explain when a bar is subjected to varying cross-section subject to different loads, that is an axial pull of 3500 newtons is acting on a bar consisting of three lengths as shown in figure. Take Young's modulus is 2.1 into 10 power 5 Newton per millimeter square, so that determine stresses in each section and total extension in the bar. Okay, section 1, 2 and 3. For these sections having different lengths and diameters, it is subject to load 3500 in both sides. Okay, length of the section is 20, 25 and 22 centimeters. That is different lengths and different diameters. Okay, we need to calculate the change in length. Previously we solved problem when a uniform bar is subject to load. Based on that we calculated change in length. But in this problem the cross section is varying, diameters and lengths are changed, so that consider this section. Note down, diameter is 2 centimeters, that is 20 mm, and length of this section is 20 centimeters, that is 200 millimeters. Next, for section 2, diameter is 3 centimeters, convert into millimeter, that is 30 millimeters, and length is 25 centimeters. Okay, convert into millimeter to 250 millimeters. Next, for section 3, diameter is D3, diameter is 5 centimeters, that equals to 50 millimeters. (22 centimeters), that means 220 millimeters. Okay, now consider the section 1. The remaining, whereas the load is common, that is 3500 newtons. Next, Young's modulus is also same. It is denoted by capital E, that equals to 2.1 into 10 power 5 Newton per millimeter square. Okay, these are all the given data. We need to calculate stresses in each section and total extension. Stresses in each section means sigma 1, sigma 2, sigma 3, sigma 1, sigma 2 and sigma 3. Next, second one is total extension, that is delta L. Okay, that should be calculated by the, every section, that is delta L1, delta L2 and delta L3. By calculating change in length in each section, by adding this we got total change in length. First we need to calculate stresses in every section. For that we need to consider section 1. Okay, sigma 1 is equals to, we know that formula, P by A. Load is 35 into 10 cube by area is pi by 4 d1 square. We know that d1 is 20. By simplifying this equation we will get the stress in the section 1 is 111.408 Newton per millimeter square. Similarly, calculate stress in section 2, that is P by A2. P is common, so that P is written as 35 into 10 cube. Next, area of section 2, that is pi by 4. Diameter of second section is 25 whole square. By simplifying this equation, we will get stress in the second section as 49.5 Newton per millimeter square. Okay. Next, similarly calculate stress in the section 3, that is sigma 3 is equals to 35 into 10 cube by pi by 4 d square. Diameter of the section 3 is 220 millimeters. Sorry, diameter in section is 30. Third diameter is 5 centimeter, convert into millimeter means that is 50. Okay, 17.825 Newton per millimeter square. These are the stresses in section 1, 2, 3. The first objective we determined, so we need to calculate change in length, that is total extension of the bar. The total extension of the bar we can calculate. The total extension will calculate, that is P by E, L1 by A1, L2 by A2 and L3 by A3. Okay, P is given as 35,000 and Young's modulus is 2.1 into 10 power 5. L1 is 200 by A1. Substitute L2 by pi by 4 d square and L3 value is 220 by A3, that is pi by 4 d square. Diameter is 50. By simplifying this equation, we will get the total change in length is 0.1837 millimeter square. Okay, it is the total change in length in the bar. Okay, thank you.